Welcome, Math 107 online students. I wanted to take a few minutes and go over problem number 3 in our last quiz, which was quiz number 4, so that you would have this information for your final exam. There was one feature of this rational graph that many of you missed, and that was that this graph has a hole in it at the point 3, -4. So let's go over how you find holes for rational functions, but in particular, how you find this hole at x equals 3 and y equals -4. Before you start to even think about graphing a rational function, you should completely factor the numerator and denominator of your rational function. So we know here, and that's to help us find the domain of our rational function, which is the set of all numbers x, except for x cannot equal 3 and 4. Okay. So that often what we do is we think that there's going to be vertical asymptotes located at both x equals 3 and x equals 4, but that's not always the case. And in particular, whenever you see a value of x that makes both your numerator and denominator 0. So in other words, x equals 3 would make both our numerator and our denominator 0. That tells us that x minus 3 is a common factor to the numerator and the denominator, which you can see right here. So one of the things that we're allowed to do is that we can reduce this function by canceling that common factor that exists, the x minus 3 over x minus 3, and we can reduce it to this rational function. So now when we look at this more simple version of the function, it looks like, hey, we just have a vertical asymptote at x. Whoops, sorry, I made a little mistake. Should be -4 here. We have a vertical asymptote at x equals 4. And this is true. But you might say, well, what about the fact that we had this x minus 3 factor in the top and bottom, and when I put 3 in, it made my top 0 and my bottom 0, which of course we know is undefined. So let's take a look at what happens if we put a 4 into our original function. We would get 4 minus 3 over 4 plus 1 over 4 minus 3 times 4 minus 4. So on the top, we would get 1 times 5, which is 5, and on the bottom, we would get a 0. So that's how we know that there's a vertical asymptote at x equals 4. When we have this situation, and you can either look at it as a value of x that makes both the top and bottom of your function equal to 0, which also translates to the fact that it has a common factor, then you know that there's a hole located at x equals 3. So I know on my graph I'm going to have 3 comma some value for y, where instead of putting in a solid dot or passing my graph through that point, I would put an open circle for a hole. Now to find the question mark, x's partner, you put 3 into your reduced function. So 3 plus 1, our reduced function is right here. 3 plus 1 over 3 minus 4 is 4 over -1, which is -4. So that means at 3, -4, I have a hole in my function. So that means when I go down to my graph here, at 3, -4, I put a hole. And as everyone just about in the class did, at x equals 4, you have a vertical asymptote. Okay, and then most of you found, because your degree of the numerator and the degree of your denominator was the same, your horizontal asymptote was located at y equals 1. So x equals 4. You found your x-intercept to be -1, 0, and your y-intercept to be 0, -1/4. And when you do your sign tests to see whether your graph is above or below the x-axis, you take your first region, which is from -∞ to your x-intercept, and you take a test value. So if we say x equals -4, we plug it into our function. And in the numerator, we get a -4 plus 1 is negative, and -4 minus 4 is negative. So we get a fraction that's a negative divided by a negative, which means a positive. So that means when you're way out here at -5 billion, you're very close to that horizontal asymptote. And as you get close to -1, your graph drops down, and at -1, we know it's 0. Our second region is that little teeny region between -1 and 0. That's between -1 and -4, which is my vertical. Oh, I'll start that again. -1 and 4, which is between my x-intercept and my vertical asymptote. So I want to know, what is my function doing? What is its behavior for any value in that region? So if I pick x equals 0, I already have my answer because of my y-intercept. My y-intercept is -1/4. So every single value from -1 to 4 will be negative on that interval. So I continue my graph and I come down through my hole, and then I hug my vertical asymptote forever and ever. Okay. And then my final test is when I take a little baby step to the right of 4. That's my third region. My third region is from my vertical asymptote out to positive infinity. I can pick any number there. Let's pick 5. And f of 5 is going to be a positive number on top and a positive number on bottom, which is positive. So that means I hug this asymptote, and when I come down, I hug y equals 1 all the way out to positive infinity. So that's what my graph looks like. And like I said, just about everyone got the x-intercept okay, -1, 0, and the y-intercept okay. And many of you did, just about everybody got the sign in each of these regions of your overall function correct, above the x-axis, below, and above. But you were missing out right here at this hole, which was 3, -4. So I hope this video helped you with that idea of how a rational function has a hole. If you have any questions, just send me an email. I'll be happy to answer it.